So welcome again. As promised in lecture 2, we say that we are going to discuss the nature of solutions to systems of linear equations in the next lecture. So here we are going to do an activity to see how a system of linear equations, to see different scenarios for solutions of a given system of linear equations. So activity. So A, solve. Actually, this will apply for all the activities to solve the system. Solve the system and graph the equations. So the first one, have x minus y equals to 1 and x plus y equals to 3. So this is the first set of equations, first set of system of linear equations that we have to solve. So this solution, or here we can actually, if we use substitution, then we can say from equation 1, x is given by 1 plus y. And so where this x in equation 2 is replaced by 1 plus y, so I'll have 1 plus y equals to 3. And this tells me that 2y equals to 3 minus 1, which is 2. So this means that y equals to 1. And then so that goes to say that x will be given by 1 plus 1, which is 2. So solution is x equals to 2 and y equals to 1. And we'll see that 2 minus 1 is 1 and 2 plus 1 is 3. And so to graph this, I draw this as my y-axis. This is my x-axis. So say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this is the y-axis. 1, 2, 3, 4 is the x-axis. 1, 2, 3. So this is 0, negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, 5, 6. So there are two equations, x minus y equals to 1 and x plus y equals to 3. So the easiest way to draw a straight line is just to get the intercepts. So for the first one, I have x-intercept will be when y is 0, so x-intercept is 1. Y-intercept is when x is 0 is negative 1. So then I draw a straight line passing through this. So that's not so. Need a thicker one. So this will be the line. And then the other one, so this way I have x minus y equals to 1. And then I have x-intercept this is be 3, y-intercept is also 3. So then the other equation will be this. So this is the equation x plus y equals to 3. And then you see this is the point, the intersection point. This is 2, 1, which actually agrees with what we know from our high school, how to solve simultaneous equations on a graphical method. So that's the first set. And then the second set, the equations are x plus y equals to 4 and x plus y equals to 2. So if we can use the same method we used in the first case, so from equation 1, x is given by 4 minus y. So when I replace this one in equation 2, I'll have 4 minus y plus y equals to 2. Minus y plus y is 0. So 4 equals to 2. This is an absurd. There's no way 4 can be the same as 2. Or even if you were to solve by elimination, then x minus x is 0, y minus y is 0. So 0 equals to 2. So this is still another absurd. So this set of 2 equations have no solutions because of this absurdity. So this system has no solutions, So let's also graph. So we'll have this as my y-axis, this is my x-axis. So 1, 2, 3, 4, y 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. So 0, -1, -2, -3, -4, -5, -6, -1, -2, -3, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7. So the equations are x plus y equals to 4 and x plus y equals to 2. Even from the word go, this was actually an absurd because there's no way x plus y can have different numbers, 4 and 2. So x-intercept for this one will be 4. Y-intercept is still 4. So if we draw the graph, we'll have this. And then the other one, x-intercept is 2. Y-intercept is also 2. And so when you draw this, so you see clearly this is the x plus y equals to 4. This is x plus y equals to 2. So these are 2 parallel lines. And we know from our high school that parallel lines do not meet. And so even, remember the solution when you're using graphical method is the point where the lines meet. So therefore you don't expect this to have solutions because there's no meeting point between the 2 lines. And then number 3, we have the equations minus 6x plus 2y equals to -8 and 3x minus y equals to 4. So using the same method we have been using for substitution, then we can say from equation 2, y is 3x minus 4. And so we'll have minus 6x plus 2 into 3x minus 4 equals to minus 8. So this is minus 6x plus 6x minus 8 equals to minus 8. So minus 6x plus 6x is 0. So minus 8 equals to minus 8. This is true. Minus 8 equals to minus 8. There's no problem with that because they have the same values. But then in the process of solving, we have lost our x, which we are interested in getting the value. But then a keen observation on these equations, like for the first one, you have 2y equals to 6x minus 8. And so, which means y will be the same as divide through by 2. So we'll have 3x minus 4. This from this equation 1. And now for these two, also when you make y the subject, you'll have y equals to 3x minus 4. Just take y to the right, 4 to the left. And so what can you say? This is just the same line or same equation. So therefore, these ones, if you were to represent them on a line, on a graph, so 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. 1, 2, 3, 4, 5, 6. This is 7. Negative 1, 0, negative 2, negative 3, negative 4, negative 5. So for the second equation, so I'm referring to this. So x-intercept will be when y is 0. So it'll be around 4 over 3, which is 1.3. So somewhere here. So it's this point here. And then y-intercept will be x0, which is minus 4. So this point here. So I'll have this line. So the blue line is what is in my second equation, which was given as 3x minus y equals to 4. 3x minus y equals to 4. But then, as we have seen from this one, for this first line, is the same thing. So let me draw in a different ink. So the x-intercept remains to be this point, and then the y-intercept remains to be the same point here. So if I was to draw that, then I'll draw this. So the one in red is what gives me minus 6x plus 2y equals to minus 8. So minus 6x plus 2y equals to minus 8. Now we see when you're solving by graphical method is a point of intersection. And we see that these two lines are actually intersecting at every point in the whole grid of the XY axis. So which means that they can take on any real values. So therefore, our system has infinitely many solutions, because at every point, those lines are intersecting. So from these three cases, from this activity, we can we can get a general case on the nature of solutions of a system, any system of linear equations. So theorem. So any system of linear equations has exactly three possibilities for each solution. Namely, one has exactly one solution. So one solution is called unique. This unique solution. Number two has no solution, like we saw in the second activity. And number three has infinitely many solutions. So these are the possibilities. Exact solution, just one, which is called the unique solution, no solution at all, and then infinitely many solutions. And then a definition of consistent and inconsistent systems. So this we define it as any system of linear equations that has at least one solution So this means unique solution and many solutions. Is called consistent. Consistent. And then a system of linear equations with no solution is called inconsistent system. Consistent system. So therefore, we have said there are three possibilities: unique solution, no solution, and infinitely many solutions. So it means that a system that is unique, that has a unique solution or infinitely many solutions is called consistent. While a system that has no solution at all, like what we saw in the case 2, is called an inconsistent system. So that's what you need to remember. And then just the last thing before we stop. Writing systems in matrix and augmented form. Writing systems in matrix and augmented form. Really, this will be a very easy for us to understand if you remember what we did in matrices in Form 3. So consider the following system. Systems. So let's start with an appetizer, like say x plus 2y equals to 3 and 4x minus 5y equals to 8. Just as simple as this. And then B, say 2x plus 4y equals to 5 and 3x minus 9y equals to 10. So I want us to do that. Write in, so 1, matrix form, and augmented form. So if you know how to write in matrix form, then it's very easy to write it in augmented form. I remember the first thing that you have to ensure is to ensure that variables in each of the equations, if x are starting, then they are in column with x's first and then followed by y. Order is very key. So here, identify the coefficient of each of them. Like for this one, the coefficient is 1. So for part A, coefficient here is 2, here is 4, here is minus 5. And then you put in brackets to mean this a matrix. And then into first variable is x, next variable is y. And then this is 3, and then this is 8. So that's what we have. And so this is what we call matrix equation. And for this other one will be 2, 4, 3, minus 9. And then we have x, y, x, y, and then equals to 5, 10. So this is what we call what I've written here for A and B. So this is B. This is what we call matrix equation from the systems of linear equations. And so this first one is usually called the coefficients matrix. Matrix. And then this is a variable matrix. And then this is the constants matrix. And so the coefficients matrix in general is usually given by capital A. And then this variable matrix is given by vector X. And then this constant matrix given by vector B. So that you can write this one, each of system of linear equations can be written in the form AX equals to B, where A is the coefficients matrix, X is the variables matrix, and B the constants matrix. So here, this is our A, this is our X, and then this is our B. Now from that one, then it's very easy to write the augmented form. So augmented form is a combination of the coefficients matrix separated by a vertical line, and then with the constants matrix. So this is what I mean. That for augmented, you just write this one is 1, 2, 4, minus 5. And then you write vertical line, and then you write 3, 8. And so for this other one, will be, you write this matrix notation 2, 3, 4, minus 9, vertical line, and then 5 and 10. So these structures from the system A and B is what we call the augmented form. Augmented form. So that's what we call the augmented form. And so once you have mastered the concept of writing a system in matrix form, then augmented form is very easy. Just take the coefficients matrix, separate by a vertical line, and on the right you write the constants vector. Or sometimes people make this, you write this as a dotted line, or you can just say 1, 4, 1, 4, and then 2, negative 5. Then instead of making solid, then just put dotted line, and then 3, 8. And this other one will be 2, 3, 4, minus 9, dotted line, and then 5, and then 10. So this is what we call augmented matrix. So you can either use a vertical line or just use dotted vertical line. All of them are accepted. So lastly, now as an example, so write the following in augmented form. So like I have x1 plus 2x2 plus x3 equals to 5, and 2x1, 2x3 plus x1 equals to 10 minus 6x2. And then B, so let's solve this one first. So this one is a good example because now it requires you to do 2 steps. First is rearrange so that we have variables in line, and then get the matrix equation, and then before you get the augmented form. So solution, first arrange in order. So we'll have x1 plus 2x2 plus x3 equals to 5. And then 2x3, so that this next one will be x1 plus 6x2, and then plus 2x3, and then equals to 10. So that now we have 1, 2, 1, 1, 6, 2, and then 5, and then 10. So this is the solution. So thank you.